Hi friends, welcome to our channel Techcorner English, where we break down the complex topics into easy to understand pieces. So today we are going to look into the basic electrical components which we always see in any of the panels, distribution box, wherever we go. Nowadays we are able to see all these three items, which are isolators, MCB and RCCB. And first we will be looking on to the basics of RCCB, MCB and RCCB. Anyhow, we will be doing a detailed video about all these three topics. But the main focus for today is how the sequence should be. Like how should we connect these three things, RCCB, MCB and isolator in a circuit, and at what order, at what particular way we should connect. That is what we are going to mainly focus on this video. So before starting the video, please do subscribe our channel, press the bell button so that whichever video we post, you will get the notification as soon as it does. So let's start. As I told you, we will look one by one about the concepts, what are the individual items. Like first one is isolator. What is an isolator? So isolator is basically a switch which turns on and off, which is controlled manually. There is no automatic things there, automated thing is there. There is no protection given from isolator. We are not getting any short circuit overload, any protection. It's just a on and off. If you turn the isolator on, the power will transfer to the next phase. If you turn it off, power will stay at that particular position. That means the second part will be isolator from the power for any purpose. If you want to turn the power off for any maintenance activities or some repairs, so whatever, you can just turn the isolator off, so it will ensure that there is no power coming beyond the isolator. So that is the basic of isolator. That's what even mentioned in the slide as well. Isolators are switches that completely disconnect a circuit from the power supply, ensuring electrical safety during maintenance and repairs. So that's what I already explained you. And second, it's manual operations. Though isolators are manually operated, providing a visible and tangible confirmation of circuit isolation. And we like some purpose isolator has a lockout provision, like means lockout tag out. So for any maintenance, if you turn it off, you can lock it out and tag it out that it is under maintenance, signed by the authority and everything, so that it is a safe, it is a part of safety as well. So whenever someone is looking at coming, they will not turn on since it is already locked out and tagged out. So to ensure it is like safer, or someone is maintaining in some other places and the DB is some other places, so we should ensure like someone is working on some places and someone else should not go and turn it on even if it turned off. So for particular purpose we use lotto. So anyway, we will be doing more detailed video about the lotto as well. So in that purpose also isolators are used, and isolators have that lotto provision as well. So that is also one added point which I just want to explain you here. And application, it is commonly used for isolate specific equipment or sections of a circuit for maintenance or repairs. So this is basic thing of isolator. And purpose and use of isolator is again safety first. Isolators prevent accidental contact with live electrical components, ensuring with safety of technicians working on the circuit. So as I told you already. And maintenance, they enable safe maintenance and repairs by isolating the specific section of circuit being worked on. And emergency situations, isolators allow for a quick and complete isolation of circuit in case of, like whenever there is an emergency, you just need to go and turn it off. Like you don't need to turn on open the DB or open the panel, then switch the MCB off. So all those kind of things can be avoided if you are having an isolator outside the panel or at the outside of the enclosure. So then you just need to turn it off so that easily the power is isolated. So it's an easy exercise as well. And now we will be looking at the MCB. Anyway, MCB, we already did a detailed video what is an MCB. So you can just click go through our channel and you can see the content. So what is an MCB? It's a miniature circuit breaker. So it's a circuit breaker which is used to protect the equipment from two types of faults. Like one is overload protection and another is short circuit protection. The short circuit is like whenever two phase wires come in contact or phase to neutral wire come in contact, it is almost like creating a small resistance path, and which will turns the current, a high amount of current to flow, which is actually the condition of short circuit. So whenever two phase wires comes got a high amount of current transferred within a microseconds or a nanosecond. So that's where the short circuit thing. And overload is something like overcurrent is whenever we connect something which is beyond the rated current or voltage, then the overcurrent should come. So in that case also this MCB works. So MCBs are safety devices designed to interrupt the flow of electricity in case of a fault or overload, and it is automatic. Like from comparing to isolator, MCB is having automatic operation. Even we can manually turn it off and on, but it is not designed for that particular purpose. Whenever there is a fault in the system, it will automatically trip. Once post we can clear the fault and we can turn it on back. So this is what, and it is resettable. That's what the third point. MCB can reset after a fault is cleared, restoring power to the circuit. It's not like one time like a fuse. If it goes blown off one time, then we have to replace the fuse. But MCB is not such a kind of device. It can be reset and we can reuse it again and again. So that's what about the MCB. And if you look at the function and importance of MCB, as I mentioned, its first thing is overload protection. MCBs prevent excessive current flow, which can overheat wires and causes fires. Short circuit protection, they quickly interrupt the circuit in case of a short circuit, protecting both people and equipment. Safety enhancement. MCBs significantly enhance electrical safety by providing a quick and reliable method to isolate faulty currents circuits, right? So I hope you understand the concept of MCB. MCB is basically for two kind of faults, like short circuit and overcurrent. So in these two applications we use MCB for getting the safety for our appliances as well. And the third thing, RCCB, Residual Current Circuit Breaker. So residual current circuit breaker, in the name itself it is there, like it's a circuit breaker which has something to do with residual current. That means leakage currents. So whenever there is a leakage in the circuit, our RCCB will sense it and will trip. So we have particularly RCCB also, we made a video about the difference between ERCB and RCCB. So you can watch that to get more detailed knowledge about the RCCB. And just for everyone's sake, I'm just telling the basic working or the basic principle of RCCB works is like when in a normal condition, in a healthy condition, the current coming and current going will be equal, like current coming through the phase and going through the neutral will be same as per the Kirchhoff's law. But if there is any fault or any leakages in the circuit, the current coming will be greater than the current coming going back, like current coming inside and current going back. So obviously, like there is some leakage, that is the reason lesser amount of current has come back. So then there is a difference between that particular point, and due to that difference the CT will sense that difference and it will activate our tripping mechanism. That's where RCCB works. So if there is any leakage, the RCCB trips. And RCCB is most important thing because it gives protection for humans, for us. So RCCB is very important. So whenever you touch in devices which is having a leakage or earth fault or something, then definitely if RCCB is there, then if you touch it, RCCB will trip, so that it will ensure that no current passes through our body. But if there is no RCCB, definitely we will be getting electric shock. So RCCB is very important. That's what even mentioning in the slide as well. RCCB monitor the current being flown in the live and neutral wires. If there is any leakage of current to earth, the RCCB detects an imbalance and trips. Safety mechanism. RCCB enters the circuit, protecting individuals from electrical shocks by preventing dangerous current flow. I hope you get to know the basics of RCCB, isolator and MCB. And coming to the most important question which we are focusing in this video was, what should be the sequence of these three in a circuit, right? So if you know the answer, please do comment. Let's see, like if you are having a proper knowledge on this, or if you are guessing or whatever, like, or if you can even mention the reason why you mentioned that sequence, that will be better for us to like understand what is your thought and whether you were wrongly understood about these things, right? So anyway, let's go without delaying. The sequence of MCB, isolator and RCCB should be like I'm explaining from the feeding side, from the grid side. The first one should be isolator, second one should be MCB, and third one is RCCB. and it's not like we randomly chosen this sequence. There is a proper reason for this, and I know like maybe many of the people will be following the same sequence because you have seen in some other panels, or you are being told to follow this sequence, but I'm doubtful whether you know the reason why it is being connected in this particular sequence. So isolator, as we just discussed in the first slides as well, like it is just a mechanical switch which provides on and off mechanism. It doesn't have any mechanism for safety or any tripping thing kind of thing, right? So from the grid side and from our house or from the panel or from the factory, this isolator should be the point where we can turn it off and on to ensure that power is isolated from the grid completely to it, so that like after MCB, RCCB, then isolation doesn't make sense, right? So first one is isolation. So you have to, if you want to isolate the complete power, you can turn it off. Rest all things, like whichever is your system, RCCB, MCB, single pole MCBs, whatever, the complete system, like if you differentiate it as a field thing or a customer client thing and our customer thing kind of thing. So client thing will be separate and our thing will be separate. There is no interlinking, like, so that kind of segregation you can make if you make isolator first. And second thing is MCB. So as we already mentioned, MCB gives protection or safety for our equipments, right, like from the overload and short circuit. So whenever there is a overload or short circuit which is going to damage your devices, then definitely the MCB will trip, because whenever there is particular fault, the MCB will trip. And third important thing is RCCB. So RCCB, if you look at from the client perspective, that is first. From the field perspective, it is the third. Like, okay, so even if we prioritize these things, first important thing is our human's life. Like, you have to ensure our safety first, then our machine equipment safety, then power isolation. That doesn't have nothing to do with the safety control. So this is the way it prioritized. Like first our safety. That is why the third thing is RCCB. That means if there is any issue, any leakage in the field, immediate effect the RCCB should trip, because it is being first connected to the like in our primary distribution network, it is first connected in the field way, so RCCB will trip. So this is the main reason. First protection priority is humans, second is machines, and third is isolation. Though this is the reason why we connected isolator, MCB and RCCB. Hope it is clear right now. And conclusion and key takeaways. So if you see, like isolator, MCB, RCCB, all the three are doing different functions, which is completely different, nothing to do with interlayer. You cannot replace. It's not an alternative as well, so you cannot make RCCB as an alternative of MCB or isolator. So all these three have distinguished different functions which are compulsorily required in a circuit. So if you bypass if you don't have a RCCB, then you are prone to electric shocks from the leakage currents. If you don't have an MCB, you are prone or you have a greater chance for your equipments to damage, or you will cause many other things like equipment damage and short circuit, all those things like cable damages. So kind of thing, like if you want to ensure that, then you have to keep the MCB. And if you want to isolate the power, MCBs we can turn it off manually if required, but MCBs are not designed for particular purpose, like every time turn it off, turn it on. That is different, like so for that particular purpose, to make it isolated, you can use isolator. So this should be the sequence which we should follow when we design a circuit or when we wire a circuit. Just ensure that this sequence is followed. So hope this video is clear, you understand the basics, the sequence and everything. So if you like our video, if you like our channel, please do subscribe, please do share your valuable comments, share your feedbacks, so that we can keep on improving ourselves and make ourselves much better, so that it will be useful for you as well. So please stay in touch, please do subscribe. So until we watch our next video, thank you, bye.